Welcome to AI for Good, the leading action-oriented, global and inclusive United Nations platform on AI. Organized by ITU, in partnership with 40 UN sister organizations, and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished panelists and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Good morning, good afternoon, good evening, and welcome to AI for Good. Distinguished experts, President Zhu, ladies and gentlemen, my name is Fred Werner from the ITU, the International Telecommunication Union, and I'm currently working as the Head of Strategic Engagement at ITU's Standardization Bureau, and also hold the position of Chief of Strategy and Operations for AI for Good. Now, it's our great pleasure to be sponsored by BIFNC, the China branch of BRICS Institute of Future Networks, and to co-organize this AI for Good webinar with BIFNC. Now, today's webinar is a very good example of AI for Good being a very global, inclusive, and diverse platform that features content from different regions and also intra-regional and inter-regional groups. So the AI for Good program is a landmark global initiative on AI for public good organized by the ITU in partnership with 40 sister UN agencies and convened jointly with the government of Switzerland. Now, the mission of AI for Good is to bring together innovators in AI to advance the United Nations Sustainable Development Goals and advance the Sustainable Development Goals and advance AI for health, climate, gender, inclusive prosperity, sustainable infrastructure, and other global development priorities. And today we're honored to have 5 outstanding AI experts from BRICS and BRICS Plus countries to deliver keynote speeches at the ITU BIFNC AI for Good webinar. Now, the theme of these speeches relates to the following of the 17 United Nations Sustainable Development Goals. Sustainable Development Goal number 2, which aims to end hunger, achieve food security, and improve nutrition and promote sustainable agriculture. Also, Sustainable Development Goal number 3, which aims to ensure healthy lives and promote well-being for all at all ages. And Sustainable Development Goal number 8, which aims to promote sustained, inclusive, and sustainable economic growth, full and productive employment, and decent work for all. And of course, Sustainable Development Goal number 17, which aims to strengthen the means of implementation and revitalize global partnership for sustainable development. And I'm very much looking forward to these brilliant presentations from the panelists. So let me once again thank BIFNC and all the experts for their support to the AI for Good program. I wish the ITU BIFNC AI for Good webinar to be a complete success, and very much looking forward to welcoming the first speaker. Thank you.
Sorry. Okay, yeah. So first of all, I would like to give a bit introduction about the AIoT, or the Artificial Intelligence of Things. So AIoT is the integrations of the AI capability into the Internet of Things system that is involved using the AI algorithms and techniques to process, analyze, and vast amounts of the data generated by the AIoT device. So they have so many applications of the AIoT that's mature our sociality, such as the smart city, healthcare, manufacturing, retail, and agriculture that I'm going to talk today. So AIoT plays a significant role in agriculture, offering the innovative solution to various challenges. So I will give some example of the law of the AIoT in the agriculture, such as the smart farming, crop management, pest and disease detection, livestock management, supply chain optimization, climate resistance, market forecasting, and the resource efficiency. So, law of the fungi in the agriculture. Let me give some overlooks about kingdom fungi. Fungi often reside in the shadow of more visible aspects of agriculture, like plants and animals. Despite being less conspicuous, fungi play a vital role in farming. There are 1,000 known of the species, which has a unique character and function in the ecological system, such as the decomposer, that they decompose the organic matter, turning it into the nutrient-rich humus that improve soil structure, water retention, and nutrient availability for plants. So fungi also form the mutually beneficial relationship with plants, associating them in the nutrient uptake and also acts as a neutral controller. As mycorrhizal partnerships, the fascinating relationship between fungi and plant roots known as the mycorrhizal partnership, they form the symbiotic association with roots of the most plant that help plants to increase the nutrients uptakes, improve the drought resistance, and also enhance the crop yields. The mycorrhizal partnerships are also vital parts of the sustainable agriculture, contributing to the healthier plants and more productive farms. For the soil magician, the fungi can break down the dead organic materials such as the foreign leaves, the crop residues, and also they secrete the enzyme that can break down the complex organic compound into the simple form. This benefits to agriculture that it can improve the soil structures and enhance the aerations or nutrient retentions. The presence of the fungi in the soil contributes to sustainable agriculture by reduce the need for synthetic fertilizer and also leads to cost saving for farmers and reduce the environmental impacts of farming. As we know also that many of the fungi causing a serious disease for the pre-harvest pathogens, the fungi can act as a pathogen during the growing season, causing diseased plants while they are still in the fields as a leaf spot, stem or loose rot, fruits and flower disease, and its impacts for the agriculture by crop loss, and this leads to the a high cost for the disease management practice such as the fungicide resistant crop variety or good agricultural practice. Ongoing research focus on understanding and managing pre-harvest fungal disease to ensure healthy crops. For fungi as a post-harvest pathogen, many of fungi as a pathogens after the crop has been harvested and stored, such as the scarlet roots, grain spoilage, dormancy disease, and also this impact for agriculture by food loss and wastes, and also important of the storage management that needs high cost like to storage is proper practice and including the temperature and humidity control to prevent the post-harvest fungal disease. To ongoing research focusing on improving the storage techniques and preventing post-harvest fungal disease to minimize food loss. As a natural pest controllers, many of the fungi is also known as the biocontrol fungi or the microparasite that acts as the natural antagonistic to plant pathogens. This fungi has remarkable ability to combat harmful plant disease, and this can be benefit to the agriculture that they can reduce the chemical pesticide that control the fungi and also enhance the crop health. The ongoing research focusing on the discovery of the new biocontrol fungi and improve their application in farm practice. And biocontrol fungi are also valuable assets in sustainable agriculture by improving effective and eco-friendly solutions for disease management. For the fungi farming and lead to the future agriculture, fungi play an important role in shaping both traditional agriculture as well as the futures of farming. They offer the wide range of application in agriculture and beyond, such as the edible mushroom that they gain popularity as a healthy and sustainable food choice, as well as the medicinal fungi or micromediations. For the sustainable farming, these fungi can help toward the low-cost use. Many of the mushroom cultivation, for instance, require a minimum land and water to compare with the traditional crop. And also the fungi can be grown on the agricultural waste product. These are converting them into the valuable resource, as well as they are the eco-friendly remediation. Micro-remediation using the fungi can be clean up the polluted soil without the harmless chemical. The research and developments about the fungi with the future agriculture is exploring new possibilities for fungi in agriculture, from developing novel species stands to discovering the new application in the farming. So role of the AIoT in improving fungal research and development. For the data mining, fungal precision that involve extracting knowledge from dataset related to various aspects of the fungi, fungal pathogen, including their genomics, enzyme, metabolites, epidemiology, dark resistance, and virulence factors. So it's played a crucial role in advancing our understanding of fungal disease, improving diagnosis and development more effectiveness. However, to build up this kind of the data that we have so far to go about the data collection or other processing and analysis. Here is showing some of the models that we use to predict, like using the AI to analyze the whole data. This can be predicted like where the hotspot and the high risk of the fungal pathogens is, or the farming practice, pathogen outbreaks, or early warning system. So to discovering the new species, the new fungal species, assisting in the identification and classification of fungi, the AI algorithm can analyze and classify fungal image in the identification of the new species. And this we can train the model, the AI model on the last dataset of known fungal species, allow them to recognize distinct features and patterns. This trained model can help to analyze the image of the unidentified species and suggest the potential match or provide insight into their taxonomic classification. For the DNA analysis, sequencing analysis, the AI algorithm also can help to improve and analyze the vast amounts of the DNA sequence data that by comparing the genetic data from unidentified fungal species to exist database. AI can help to identify the similarity or different, potentially leading to the discovery of the new species. This can assist in the prediction of the fungal taxonomy based on the genomic information, aiding in the classification process. So for the environmental monitoring and sensor data analysis, AI-powered system can analyze the environmental data, collecting across various sensors such as those of the measuring temperature, humidities, or chemical compositions. By correlating these data with a fungal occurrence pattern, AI can identify potential regions or habitats where new species may exist. Additionally, AI can process large volume of sensor data in real time, providing continuous monitoring and researcher to any significant finding. And the data integration and collaboration, this AI can facilitate the integration and analysis of the diverse datasets from multiple resources, including ecological survey, taxonomic database, and environmental monitoring record. By combining the analysis of this dataset, the AI can help to identify the unique fungal species that may have been overlooked in individual study or datasets. So AI also can provide a valuable assistance to discover the new fungal species. However, the humans' expertise and the domain of knowledge remains crucial for validating and confirm the finding. Then the AI should be seen as the supportive tool that enhance the capabilities of the researcher rather than to be the replacement for their expertise. So right now we are bidding farewell to conventional farming practice and enhance and embracing smart, automate fungi agriculture system. This system offers precision, sustainability, and enhance yield, making the pivotal shift into the agricultural landscape. As we step into the futures, our agricultural landscape will witness unprecedented sophistication and the fusions of AI, OT, and fungi hold the promise of the resilient crop, efficient pest management, and sustainable agriculture. So the future is like with the possibility, and our journeys will lead us there. So thank you very much for your listening.
All right, thank you. Thank you, Cora. Just a second. Okay, I have a presentation today that is called Advanced Spectrogram Analysis for Respiratory Disease. It will be not that scientific boring as it sounds from the name of the presentation. A few words about myself. I represent BRICS University of Future Networks. I'm a United Nations expert as well, and my major is artificial intelligence. And today I want to cover the topic that touches cough recognition via spectrogram analysis. We all remember COVID times, and during COVID times, as a scientist, a scientific society, and me in particular, who was in charge for R&D of the project called the Custody, we found that most of the doctors who actually work with respiratory diseases decided not to meet with patients for obvious reasons. And they wanted to do the analysis distantly. That was totally impossible because you cannot cough in your phone and send the recording to somebody because the phone does a lot of distortions to the sound. So we decided to move sound to the picture. The picture you can see on the screen. It's called spectrogram, and apply artificial intelligence to analysis of such spectrogram to extract certain signs that are specific to COVID cough. And the accuracy, as you can see on the screen, was up to 95%. And there were medical validation that went through several esteemed peer-reviewed journals in the States and in Japan. And we made for countries accept the methodology and implement it on the national scale. Vietnam was, I think, the best one, the fastest one, because it was officially signed by the Ministry of Healthcare and was approved to be used in parallel with PCR tests. And it was highly covered in media all over the globe, especially in China, where the cough fight was quite severe, and new technologies are widely used to tackle new challenges. If we deep dive a little bit into the subject, doctors were strictly against and are strictly against using cough analysis in parallel with PCR tests. It's a new methodology. During COVID time, it was easier. Say in Vietnam, there was lack of PCR tests, and it was better to use this screening tool that was not tested yet than properly in time. Now, when we don't have this emergency state, we have segmented, and this is properly accepted by doctors all over the world, any tests into 3 segments, as you can see on the screen: PCR testing, express testing, and screening. So basically, analyzing your cough for different type of respiratory disease is the best screening methodology because everybody has phones, and it's easy to do the screening fast and very, very cost effective. And it can be used on the phone and on any of the smart devices. We also tried and did it for multiple devices. Everything can support this small app, small library for donating your cough. And hospital backup, of course, is absolutely necessary. because AI, as we know, and ethically cannot now make diagnostics, so there's a lot of limitations on it. So doctors can always have this option to verify diagnostics from AI. And in screening, if you don't go to diagnostics, but if you go to screening, it's okay to tell to the patient itself how we can classify his cough, his or her cough. But it depends on the country. And of course, we are why we promote this new technology is to, and especially on this summit, is to pay attention to United Nations, the World Health Organization, to this new technology, because obviously new viruses are here and they will come soon. And there are a lot of, there is a big potential that something like COVID or COVID itself will come back. And in many developing countries where we saw PCR tests were not there at the time, or the governments didn't have budget for this, they can use this small approach, this new approach, to stop viruses or make proper diagnostics, because we all know that early diagnostics and restrictions of social contacts leads to sharp decline in the number of people who become ill. And nowadays we already made first trials with the Ministry of Emergency Affairs in Kyrgyzstan and Central Asia. And the results are quite good, because we can stop and detect viruses spread distantly, very fast, and very cost efficient. While there is no emergency, we also applied the same AI tool to asthma, analysis of asthma. You can see here the typical increasing asthma severity graph. So everybody who has asthma, they know that there is differentiation between mild, moderate, and severe asthma. So it can be done via acoustics as well. So basically, if you cough to your app, you can understand, not you, the doctor, based on statistics, can understand when you have certain mild, moderate, or severe strike. And this is important statistics. But what is more important, and where AI plays a vital role, and that is being tested in the United Arab Emirates now, is, asthma. When you have symptoms of asthma, most people don't know what causes this asthma strike. It can be new food, it can be playing with a cat or with an animal, it can be touching grass or plants. It also can be because of your location, weather, and your exercises. So the application that we design now uses AI to correlate these parameters. Most of them are collected from sensors on the phone. Others you just confirm in a pop-up windows. And everything goes to the proposal. AI makes a proposal on what can cause asthma based on analysis of your parameters, and also based on clustering of all other patients that have the same paradigm, the same pattern of having asthma cough. And doctors now cannot make this analysis by themselves, too much data. But AI does all the job, provides this information to the doctor, and the doctor can make the confirmation. This is how the doctor interface looks like when he works with something like this. It's a very good statistical tool for the doctor, very easy, one click, basically. And what's more interesting now, being in the preclinical trials, we see that asthmatic people, say, for example, just for example's sake, you can see on this screen, it's Dubai, and there are areas in the region where you obviously have more severe strikes and less mild and moderate, and there are other areas. So basically, we already have enough data to predict how people with asthma will feel themselves in different parts of any city based on the statistics that we are gathering. So, and AI, again, is playing a vital role and can actually play a big role in fighting asthma, because before, and we have strong understanding about it, doctors didn't have enough tools to process this amount of information. And the last but not the least, to finalize my small report, is federated learning. Federated learning is, just to expand a little bit on the scientific term, is a new mathematics behind AI that allows to transfer knowledge, not data. That means you can see on the screen there is a central server that sends AI agent to some hospital, for example, where data is stored, patient's data is stored. You can see it on the screen. As this agent is trained on the data in this hospital, say in Emirates Rashid Hospital, for example, and comes back without the data. The data is not being transferred, it's illegal, but the knowledge of certain patterns, say of asthmatic or COVID coughs, can be transferred. And then it merges on the server becomes more and more intelligent, and we do not violate any laws. We already implement it on the country level, in the country, I mean. It would be also great to make it a good mechanism approved maybe by World Health Care Organization to make it international. Then we can educate our AI tools much better. And for viruses, new viruses, not only asthma, but for new viruses, it can be essential if something new outbreaks like COVID did. We can easily train the big AI potentially on the World Health Care Organization servers so that to stop the disease spread. Okay, thank you very much. And the questions, I believe, are at the end of the report, of the session.
Yeah. Good morning, good evening. So my name is Zhao Liang. I'm a full professor of the University of São Paulo in Brazil and the co-PI of the Center for Artificial Intelligence. So today I will talk about pattern-based machine learning and some applications. Also, the development of artificial intelligence achieved great successes. There are still some challenging problems, such as how to integrate data future from heterogeneous and dynamic data source, how to interpret the decisions made by machine learning algorithms. So in order to solve this problem, we propose pattern-based learning using complex network theory. This is because that the inherent advantages of networks enable systems to capture associations in the spatial, topological, dynamical, and functional aspect of large data sets. So in these figures, the left-hand side of the figure illustrates that computers make a classification by future similarity criteria divided in car body, car door, car tires. The right-hand side shows that human beings make classification considering pattern formation. In this case, consider the organizational structure of the objects. So traditional data classification considers only physical features, such as distance similarities or distributions of the input data. Here, we call it the low-level classification of future-based learning. On the other hand, the human brain performs both low and high order of learning, and it has facility in identifying patterns according to the semantic meaning of the input data. The data classification that considers not only physical attributes, but also the pattern formation is referred to as a high-level classification or pattern-based classification. So for the last years, we have developed three pattern-based learning approach. The first one is according to pattern conformation. The second is according to importance concept. And the third one is a classification of dispersed data pattern by core peripheral network modeling. So if you are interested in these topics, please refer to the papers shown in this slide. So now I present some applications of pattern-based learning. The first application is molecular detection of oral cancer using complex network. This work has the objective to develop cheap and non-invasive method for oral cancer detection, especially to benefit low-income people. This is also an example of AI for good. Another application is the classification of common etiology. We classify common etiology into 4 categories, combining EEG signal and the patient information. So our work suggests new possibility to assist physicians in the detection of the common etiology, especially to assist those physicians in small and far healthcare units. So in this paper presents a COVID-19 transmission dynamic study at the early stage from a network approach. This article generated a significant response in the major Brazilian national media outlets. Another application is a histopathological image classification for tumor detection by a new graph neural network developed by our research team. So another application is the stroke diagnosis by classification of magnetic resonance images. Stroke is the main cause of disability and the second cause of death in the world. A rapid and accurate diagnosis is a cornerstone of effective stroke management and prevention. We have also developed a time series trend detection technique using pattern-based learning. Here, each trend is represented by one or more communities of the network constructed from the time series. Then trends are identified by community detection. In this way, we study time series in the topological space instead of the time frequency space. We have applied this method to Brazilian stock market trend detection, and high detection precision has been obtained. We have also developed a new type of network model called TroNet and apply it to global file analysis. In this application, we have developed a mobile tool for the detection of coffee maturation. With this tool, users can accurately determine the optimum time to harvest the coffee beans, resulting in improved coffee quality and reduced waste. So AI for good refers to use of AI to address challenges and make a positive contribution to the world. On the other hand, AI for bad refer to the use of AI for malicious, harmful, or unethical purpose. Some examples of AI for bad are deepfake videos, malware and cyber attacks, fake news, and disinformation, financial fraud, privacy violation, and so on. So pattern-based learning is suitable for security issues by defending the system from malicious use of machine learning techniques through a double check, a data future check, and a data pattern check, or data sub-pattern check. So we have developed a pattern-based outlier detection technique. Let's look at this figure. The middle red data point in this figure would not be considered as an outlier by traditional technique because it stays at the center of the data points. But it is detected as an outlier by pattern-based learning because it does not conform to the patterns of the blue data points. So pattern-based outlier detection will be quite useful to prevent intentional misuse of AI in the tasks such as detection of fake news, detection of intentionally manipulated photos or videos, and detection of intruders in computer networks. So the basic idea is typically in instance of fake news or manipulated photos, videos, there are a genuine test photo video alongside the manipulated ones, the outliers. The manipulated sub-patterns usually do not align with the regular pattern. Therefore, we can identify such bad sub-patterns by pattern-based learning. So in the future, we will collaborate with BIFNC in two main areas. The first area is Brazil-China collaboration for smart agriculture system development. Brazilian agriculture is an important sector of the country's economy and plays a significant role in global food production. Brazil is one of the largest agricultural producers in the world and has a diverse range of products. So the second area is Brazil-China collaboration for AI-based cancer research and development. Cancer research plays a pivotal role in understanding, preventing, diagnosing, and treating cancer. Its impact extends beyond the medical field, influencing public health, economics, and the overall well-being of individuals and communities. So this is our book on pattern-based learning and its Chinese version. So I'm profoundly grateful to the China branch of BRICS Institute of Future Networks for their invaluable support and collaboration. Thanks for attention.
Okay, and my understanding, I'm the last speaker today, and it's really like to look at the AI for mountain people, and the most marginalized the community and in the planet. So I work on mountain future and basically building the future living style and what's connect urban rural area. Next, please. So basically, I'm based in Yunnan, and we like to look at the global level, how to connect the mountain people. And that's my today's talk, and look at the how from one side to put in larger scale, the second through market value chain, the third how to looking for research for development, finally, and my side and how to connect the world at the global level through the AI. Next, please. So global mountain covered one-fourth of global the Earth's land area, and but they're very diverse and which provide large ecosystem services in terms of biological diversity, 80%, and also 60% fresh water, and a very rich cultural diversity in the say natural resources. Next. So mountain are produce not only food but also say coffee, cacao, and coffee from Ethiopia, cacao from Andes, and the tea from Asia mountains, and very important at the global level. That's also the image we present at the mountain landscape. Next. Next, please. So we work on the global challenge and the solution and the climate change, sustainable value chain, and climate both adaptation and mitigation, soil and the land, and also governance and the social inclusion of a solution market value chain. Next, please. So we have one site which is 420-hectare land based in Dry Valley of Southwest China, was jointly supported by Chinese Academy of Sciences, Chinese Academy of Agricultural Science in 6 years ago, and so we're linked to UNEP and FAO, and also with C4 EQUAF, and also the International Mountain for International Center for Integrated Mountain Development. So that's our partner. Next slide, please. So we try to use AI technology and to monitor at the global level and dry land, dry valley, and include savanna vegetation. We built our feed station. We have a germplasm collection, and we have also Shanghai, Yunnan province, science technology demonstration park. We have a circular agriculture, use AI technology. Next step. Next slide, please. So we have a living germplasm. We have a monitoring network. We have agroforestry demonstration. We have a circular agriculture industry zone. Next, please. So we are based in Southwest China, but linked to South Asia, and also the Sahara region of Africa. So basically the dry land in the tropics. And we have very hot, dry condition, but along the elevation gradings move to highland area, and we have a UNESCO heritage site, the rice paddy field. So that's the from the global latitude to temperature gradings to elevation gradings. That's what we try to work on. Next, please. So with AI technology, we can demonstrate how Asia connects to Africa through the tropical savanna, and that's our agroforestry center are based in the Kenya, and that's part of Africa savanna region. So we mainly focus on red zone, the dry, hot savanna vegetation, which is much larger than tropical rainforest area at the global level. Next, please. So that's the area we work on, river valley, savanna, and in our region, we only have 20,000 square kilometers total area in the part of Yangtze, Salween, Mekong, and the Red River. Next, please. So that's the landscape we work on, very mountainous, and compared to open savanna in Africa, it's a totally different vegetation. Next, please. So AI technology basically link agriculture innovation with green, low carbon lifestyle in the urban area. Both, so we try to look at both rural and urban through building new lifestyle through the mountain products linked to daily life in the urban area. Next, please. So we're doing scientific observation and monitoring. We're doing research and the development innovation. We're doing international collaboration. We're doing market value chain. And then finally, we do public education, mainly through the video and the interactive way with nature. And we have a partner like Deep Nature we work with to allow us to see and the wildlife in the natural habitat. Next, please. So that's basically a component we work on. We have a lemon garden, we have a savanna park, we have a Shanghai Yunnan Science Technology Park, we have a fiber academy, we have a traditional rice heritage site and a learning center. We have a training center, we have an international center, and we have sheep breeding center use AI technology. So our philosophy is learning, experiencing, co-innovate, and sharing. That's our approach to use AI technology. Next step. Next slide, please. So in how we incorporate in AI into research and the development, you need a scientific mind, we need a value chain, we need a collective impact, and the social innovation, bring technology from farmer to urban use. So that's the people to people more important through the AI technology. Next step, please. So that's about the intensive what's called close to nature agroforestry system. We use this for ecological restoration, incorporate into new products through the superior germplasm and also the bio products we produce and for urban area. Next, please. So by combination with all AI technology, we use for restoration and farming, and then we incorporate into animal husbandry. Later on, we bring to say new type, new quality products to urban consumption area through the AI technology. So that's the model we're developing. We include the solar panel for the as an energy supply also. Yeah. Next, please. So that's the partnership where we're building up from Asia Mountain to Africa, East Africa landscape by bringing the new fiber value chain and to support the Africa farmers. That's we are working on that. Next. So that's our plant based on Africa savanna we develop into Kashmir type of fiber, which is high quality and for high-end market in the Shanghai, in the Chinese urban area. So that's the demonstration we put in bring the Asia, Africa farmer to Asia consumers together. So that's the example we are doing now. Next. So that's through the visualization, through the AI technology, through the products flow, and through market chain, how we bring together from scientific exploration, ecological restoration, and the Asia with indigenous wisdom based on local smallholder and the traditional farming system. Finally, we built a new type of lifestyle for young generation living in the urban area, and also we educate local youth, young generation in rural mountain, and we bring mountain people together, and through the new value type of chain to support the conservation for the mountain, particularly marginal ecosystem like a tropical savanna. So that's my summary, my presentation. That's contribute how AI technology bridging not only digital gap between rural and urban, but a particular telecoupled link between Asia and Africa farmer together. So thanks for your attention.
Thank you very much, Jianchu, for your presentation. And in fact, thank you to all of our speakers for their presentations. We got there in the end, which was great. And thank you to our audience as well for your patience. So we now welcome questions from our participants on the neural network. We have one already, I believe, for Xiao Liang from Madhavan Palan, which is, what is the social impact current and projected of the project? So I believe that is for Xiao Qian.
Thanks for the question. The pattern-based learning is somewhat different from your learning, including the deep learning. So we consider the pattern formation of the data. So we believe this approach can achieve a higher level of learning, which is more similar the rationale of our brain. So we hope this learning technique can be useful in the smart agriculture, in the disease detection applications, what we are doing now.
So it remains for me to say thank you to our speakers and their presentations once again, and to our participants. We look forward to seeing you all again on the neural network very, very soon. Thank you very much, everybody.
Thank you. Thank you.
Thank you very much.
Thank you.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the e-shop, and build your personalized AI for Good program. Let's shape the future of AI for Good.